Okay. Is that making sense, Mateo? Yeah. Awesome. Okay, so we're going to kind of review fractions by learning about a pretty common way that fractions get used in math. And so, yeah. So we're going to talk about the idea of ratios, okay? And then from there we'll build a little bit. So I think based on what we, worked on and talked about in class on Monday, I think everyone felt pretty good about fractions, what they mean, and stuff like that. So hopefully everyone's feeling good about this. So we can kind of visualize fractions as, right, we think of this whole rectangle here as one, right? One whole rectangle, right? And then it's divided into 10, right? Equal parts, okay? And then, right, we're only concerned with 3 of the 10 parts of the whole, right? So we can represent this visual as a fraction like this, okay? So another way to think about a fraction is to think about it as a ratio. And what it tells us here, right, is that a ratio is a comparison of one number to another, okay? And so a fraction is a specific kind of ratio comparing a part to a whole, okay? So when we, once again, if we think about our image, we think about the image that we have up here, right, at the top of the page, we could think about it as, right, 3 shaded parts versus 7 unshaded parts. We could think about it as, right, 3 shaded parts to 10 total parts. Or we could, right, make this comparison of 7 unshaded parts to 10 total parts, right? So hopefully this makes sense, right? We're doing some kind of comparison between numbers, okay? And we're representing it numerically as a fraction. And once again, it helps us see, right, the two numbers that we're comparing, okay? So just remember that a ratio isn't a fraction, but a fraction is a ratio, right? But hopefully. So when you encounter a ratio, you might see it written in one of 3 ways, right? So we have the fraction form that we just looked at. In math, they use the colon, right? These 2 little dots standing on each other, one atop the other, right? To represent it. So this would be a ratio of 7 to 3. Okay. Or, right, like I just said, right, when we say a ratio, when we speak it, we usually say, right, a ratio of 7 to 3. Okay. So, little bit of a hint here, right? The order in which the number appears is very important. Okay, because of course, right, 7 represents one thing and 3 represents another thing. So we always have to keep track of, right, how we've ordered ratio to make sure that, right, we're representing it correctly. Okay. So go ahead and just look down at the bottom of this first page. Okay. So, okay, so see if you can write out these 4 ratios based on what we see here, right? So if we have the ratio of apples to lemons, right? You're going to say how many apples are there? How many lemons are there, right? And then write it again in the word form, okay? So I'll let you guys work on these 4 just to warm up. Let me know when you're ready. Hopefully the concept makes sense. It's a little. It does sound kind of good. A lot of good comments. Right, how many different ways can we group these items, right? Everyone ready? Got your 4 ratios all mapped out? Yeah, good. Hopefully you folks online are with us. You're always welcome to chime in the chat or turn your mic on and weigh in on this stuff. Okay. All right. So what is the ratio of apples to lemons?
5-4.
Good, right? Oh, I see. So the fraction was in the middle there. That's what that is, right? So 5-4. So you just write it across the board. Excellent, very nice. So hopefully everyone is gathering, right, what we're doing here. Good. So what is the ratio of lemons to apples? Yep.
4/5.
Exactly, okay? And so, you know, it's really up to the person creating the ratio to decide how they want to order and compare the things, okay? What about apples to total fruit? Good, 5, 9. Very nice, you guys are killing it. You're just gonna start off nice and gentle. So then what about fruit to lemon or total fruit to lemons? Total fruit is 4?
4 to 9.
9 to 4, right? Because remember,
9 to 4. Yeah.
total fruit is first. So even if you have, right, even if it looks like an improper fraction, when we write it in this style, it's, we still don't want to like convert it into a mixed number or anything. So it's okay to have, you know, to represent your ratio as an improper fraction. Because just like it's saying here, right? The order matters. We're always going left, right. Excellent. Mateo, you good? You getting it? Sweet. Yeah, I know. Easy peasy, lemon squeezy, right? Cool. So you guys are catching on nicely. I don't know if we need to go into any of the other exercises on the next page. Basically doing right the same thing as the apples and lemons. So as long as you guys are feeling good, we don't necessarily need to do this extra practice. You guys can do that at home, unless you want to. You guys feeling good about at least kind of making the ratios? Okay, so like I said, if you wanted to go back and do exercises A and B, you're more than welcome to. But you guys are too smart, you don't need it.
Sure. So like when a ratio like refers to like odds,
Mm-hmm.
like how does that work? Like as far as like, you know, like 5-1 odds or 4-1
Right,
odds. or-
yeah, so that is through calculating a probability. So the first number in the ratio is the likelihood of you getting whatever you want, right? Like, so if we had a 6-sided die, right, and we wanted to say, what are the odds of rolling an even number, right? Well, we have a 50-50 chance, right? We have a 1 in 2 chance of rolling it because it's 3/6, right? We have 3 possible hits that we can get out of 6 total possible.
So, but as far as like, I guess when the numerator is bigger, is that like worse odds or better odds?
I don't know if you can have odds where the numerator would be bigger, because you could never be more than 100%.
Huh.
Right? So you can have like 100% chance, but I don't think you can have more than 100%.
So I've seen stuff like, you know, like 11 to 1, 5 to 1, 4 to 1, like.
Oh,
for,
okay,
Like. I've seen it in,
Yeah.
like horse racing. So
right,
That's like
right.
weird, but
Yeah.
I just always wonder what that meant.
That's a good point, yeah, so I mean, I'm not sure like the equation or formula that they would have to create betting odds. But once again, it's like. I mean, right, the higher the number gets, right, the less likely they are to win, and therefore if you bet on them and they did win, right, your winnings would be higher, so I think it has to do, right, where like. I'm betting 1, and if I win, I get like 11 times my bet, maybe. So like a 2 to 1 would be like a more sure bet, right? Because they're saying that it's more likely that that horse would win the race compared to the 11 to 1. Yeah, no, that's a good question. Yeah, we have. Yeah, we do probabilities, but yeah, it's a little different than those like odds for sure. Yeah, no worries. Thanks, Liz. Oh wait, here's the assignment, but let me go ahead and grab that. Sorry, I'm gonna add you to my class list to make sure that I get you in my. Yeah, good question. All right. Okay. Let's just look down at the little note here in the bottom of 137 once again, just to get an insight. Hi, Spencer, come on in. No worries, dude. All right. So kind of like what I was just talking with Camden about a little bit. Because ratios are in fraction form. You can reduce them like fractions as well. So for example, right? So like fractions, ratios must be simplified to lower terms. I guess I didn't get that chunk, but I mean, it kind of makes sense because we want to boil it down to its simplest form. So hopefully everyone feels confident when we talk about a fraction, we talk about simplifying or reducing it to lowest terms. Hopefully everyone knows what we're talking about. Cool. So for example, a ratio of 2 to 4 should be written as 1 to 2 or 1/2, right? A ratio is never written as a whole number. For example, the ratio 6 to 3 is written as 2 to 1, right? It would not just be a ratio of 2. Does that make sense? So a little different from fractions, not too far. Okay. So yeah, so here's kind of our next little chunk onto that. Okay. Okay, so we already looked at this a little bit, so this should just be review, right? But so just kind of dipping our toe here. So we're on the second page, Spencer, I think you can find it. So we might see something like Eleanor typed 27 pages in 4 hours, right? So her rate of typing, I guess, right? I'm trying to think like how long would it take? I guess it depends on what you're typing, if you're writing as you're typing, or if you're just typing. Anyway, sorry, focusing, so hopefully that makes sense, right? And then, of course, we can see that it cannot be reduced down, right? There's 24 or 27 and 4 can't be reduced, okay? Next example, the Abelo's rec room is 25 feet long and 15 feet wide. What is the ratio of the width to the length, right? So once again, you just read the question carefully, right? And put your numbers in the correct order. So width is 15, length is 25, and then yes, right? We can reduce 15 over 25 by dividing a 5 out of the top and bottom. So the ratio of width to length is 3 to 5. Okay, so yes,
Does it have to be in whole numbers? Like
whole
ratio?
numbers? No.
Like, can it be like 3.5 or something?
Yeah.
3.5 or something.
Mhm. Yeah, when you get, yeah. Because a lot of times, right, you use, one of the most common ways that you use ratios is to like produce like scale drawings or scale renderings of something. So of course, like an architect's building, right, that they've designed, right? They can't show you the whole building, but they make like a little model, right? And so of course they want the size of it to be like in proportion to the building that they're gonna make. Anyway, yeah, so that's often what we use ratios for a lot, or like for me, I'm always like having recipes because I only have to cook for like 2 people. So, so I do a lot of, like, okay, if it's this much, how much is it if I cut it in half kind of thing. So those kind of things help me figure it out. Or, yeah, how much water to salt when I'm boiling peanuts or something like that. Okay, so hopefully everyone's feeling good about this. Shouldn't feel too challenging, hopefully. So, all right, so here's another way that we use ratios, and we'll probably see this on the test. So we can use ratios, right, to convert units. Okay. On their last job, Mario worked 2 hours while his brother worked 30 minutes. Wow, what a lazy brother. What is the ratio of time worked by Mario to the time worked by his brother, right? So we first have to say, okay, well, we have 2 different units here, right? So we have to change one of our numbers so that the units match. And so we'll take our 2 hours, right? And hopefully everyone would know that 2 hours is the same as 120 minutes. Then we create our ratio, then we, reduce it down. So of course, Mario worked 4 minutes for each 1 minute his brother worked, right? So we keep the units attached to our ratio, and then we can talk and compare, right? You're like, hey bro, for every 4 minutes, I work. Does that make sense? Mateo, you got a question? No? If you ask questions, then I can drink coffee and not feel like I'm taking away time. No. All right, let's look on the next page. So we've got 10 questions here. I think you guys should be okay on these. So go ahead and just take a few minutes. Make sense what you're supposed to do. If you're completely lost, let me know. But I feel like with our warm up with our apples and lemons, I think you guys will be okay with stuff. Your head fell off.
Anyone, do either of y'all have to? Spencer, Mateo, do you guys need calculators? Yes? You don't really have to worry about number 10 unless you're really in the mood to write more ratios, but I think 9 is plenty. But, you know, don't let me stop you. Maybe another 3 minutes or so, or do you guys need longer? Okay, sounds good. Thank you. All right, you guys still working a little bit? Ready to talk about these ones? Yes, no, maybe so. Okay, awesome. Shouldn't have felt hopefully too impossibly hard. So what is our ratio of unbroken to broken figurines? 14:4. I see 3 broken.
There's 4 broken, 1 piece in a lake.
Oh, you're right. Thank you. I see that now. Oh, yeah. Oh, yeah. Maybe I should just read the actual thing because that makes it a lot easier. So 14:4, can we reduce that down?
Yes,
Mhm.
7-2.
7-2, right? We can take always make sure you're reducing if you can. Okay, how about broken to total?
4-18,
Okay, can we reduce that?
2-9.
So for every 9 figurines, 2 are likely to break, or I guess 2 broke. All right, and then total figurines to unbroken. 18-14, and would we reduce that? That's okay.
27.
9-7, yeah. If it's even, we can always. Awesome, okay. Out of a total of 12 free throw attempts during last night's game, the Warriors scored 9 of them. Warriors player Brad Clayton scored on 6 of the free throws. So what was the successful to total attempts? Good, can we reduce that? Good. So for every, right, 4 free throws, they made 3 of them. Guess they're not talking about Golden State here. Hopefully it would be higher. Well, it's not horrid, but anyway, sorry. Right ratio of Clayton's successful free throws to the team's successful free throws. So what would that be?
6-9.
6-9. Can we reduce that? Good. So flood coming. Bye.
What did it say?
Flash flood warning until 5 p.m. Oh, wait, that's. I always dismiss it and then it
I always
moves to the next
dismiss it
one and I'm
too.
always like, oh crap, I didn't mean to make it go away. Like, go away. I'm bad at my emergency alerts on my phone. Well, it's a good thing I have my jacket, my raincoat. Okay, good. So for every 3 free throws the team made, right, Clayton made 2 of them. All right, and then Clayton's successful free throws to the total attempts. 6-12, which would reduce to 1-2. Yep, good. So Clayton made every one out of the 2 free throws the team attempted. Okay, so you can kind of see how ratios, yeah, help us kind of, think about sports statistics, stuff like that. And it's probably stuff we kind of think about anyway. All right, so now we have a nice table of data here about System Set Incorporated. So it says write a ratio, number of support staff to the number of directors.
5.
Okay, so does that reduce? Good. 7-1, yep.
good. So for every 7 support staffs, there is 1 director in this company. Ratio of sales managers to sales personnel. 5 to 20, can that reduce? Good. I guess each sales manager has 4, maybe 4 sales personnel that they oversee. That's a pretty nice ratio, I suppose.
Over at Honda, it's like 1 to 6,
Have you worked there for a long time?
just a few months now.
Thanks.
It's not for me.
No worries. It's always good to know that and be honest. How about support staff to total employees? You guys get 92 for the total?
Yeah.
Okay, I'll believe you
Easy
guys.
calculator.
No, that's fine. Can we reduce 3592? You take a 7 out of 92? I don't think so.
Comes out of some like really big decimal, right?
Yeah, so we can't reduce it down to that. But we can see that support staff almost makes up half the staff, probably, and the biggest portion of the staff. Good, so you guys are catching on nicely. Like I said, this is just kind of the beginning point, but everyone seems to be doing well. Are you folks on Zoom following along okay? Any questions or concerns? Luba, I'll go ahead and put the, I don't know if you joined when the jot form was in there, and then, here's the lesson we're working on. I do have 2 extra copies that I'll put in the binder for folks to pick up from campus if you want. Okay. Everyone's feeling good, no questions? Excellent. Okay. So I think we saw this before, and once again, this is just kind of getting us, you know, in a good mathy headspace. I'm pretty sure that's the technical term. So of course, we can see, right, that with our ratios, there's patterns here, okay? So of course, can you guys figure out the pattern for the denominators here? Yep, right, so it would just be our even numbers, right?
10 by 2, yeah.
So of course, we kind of see, right, that all of these are equivalent to each other. They're just different forms. Okay. You should have put a 4 in the first box. So numerators increase by 1, denominators increase by 2. Hopefully everyone's kind of seeing the pattern. Shouldn't be too hard. So then an example here. Out of every $5 that Martha earns, she saves $1. If Martha earns $15, how much will she save? So are you guys seeing that pattern? 3, yeah, good. All right. $2. So of course, dollars increased by 5, dollars saved increased by 1. So just recognizing those patterns, you guys seem to be doing fine. So then, right, no matter how much Martha earns, her ratio of earnings to savings is 5 to 1. Okay. What a responsible individual. Okay. So go ahead and see if you can find the patterns here in these 4 scenarios. Okay. And we'll go from there. And then B, in your own words, describe the pattern in each chart above. So it's telling us for chart number 1, as the pounds increase by 1, the pieces increase by 16. If each piece of chocolate must weigh an ounce. Is it still working? No. Okay, so a little bit more, couple more minutes.
All right, let's go ahead and look at these ones. Hopefully everyone's just kind of seeing how this works. And once again, right, we're just kind of these, right, the ratio is the same, even though the numbers are changing, right? So in every pound of chocolates, there's 16 pieces of candy, right? So we know, right, that we should fill in our box. I don't know if I can go 48. So, right, right, pretty straightforward, right? As the pounds increase by 1, the pieces increase by 16. Excellent. Okay. Out of every $100 spent in its supermarket, Grand Grocery will donate $4 to local schools. So, right. What goes in the top box up here? 300. Good. Cool.
Start spending real big money, there's really not a lot of money doing.
I know. I mean, they must have pretty high daily sales, hopefully. Cause yeah, I'm like, yeah, why don't you just keep the money?
Maybe that's why our local schools are so underfunded.
Am I? Yeah. Good, okay, and every dollar, there's 20 dimes. Or sorry, 10 dimes or 20 nickels, right? So. Then $2. Excellent, good. So, yeah, right, as dollars increase, dimes increase by 10, nickels increase by 20. Okay, the Chandler's hourly take-home pay is $27.75. In 1 hour, Mr. Chandler takes home $13.50, and Mrs. Chandler, how progressive, takes home $14.25. So I need to think of take-home pay as a couple. So we know that Mr. Chandler. Okay, so after 2 hours of work, how much is Mrs. Chandler making? 28.50. And then what would 83.25, so we're just adding, right, 27, yeah, good. Okay. 42.50. Thank you. Okay, and then 4 hours of total take-home pay. 511. 111. Even. Which one? 54. Okay, and then 5 hours of work. And how much is Miss Chandler making in 5 hours? 71. All right, thank you. Cool. Good, so you guys are catching on nicely, and once again, right, we're just seeing how these ratios work, right? And so they change at, right, a constant rate, and that's what we're really trying to see and take away here. So hopefully everyone's feeling good about that. Any questions or concerns or problems at this point? Okay, let's take a break then before we move on to the next section. So yeah, go ahead and take a 10-minute break, and we'll come back at 11:05 and get rolling some more.
Doing good, I mean,
All right. You checking on my probation out there this morning?
fun.
Yeah, just my conditions of release and stuff. I've been trying to find an apartment here. It's been hard lately.
It's tough.
Yeah.
You got a job?
Mm-hmm.
Where you work?
Work at RWQ Trucking.
Oh, cool.
Mhm.
So do you drive or do you?
Right now, I don't have my license. I have a vehicle, but they don't want me driving.
So you're still training?
Mhm. Yeah.
You still get paid for training, though, right?
Huh?
You still get paid for training though, right?
Mhm.
Good.
Well, I'm not training, I'm actually working, I weld and I told them I'm like a mechanic for them.
Oh, really? That's cool.
Yeah. I used to iron work before, I went to school at Polk Welding School.
Pretty cool.
So I'm bachelor's in welding, so. Right now, I'm just waiting to clear my own license, so I'm waiting on Colorado. Let me pay for my $900. Yeah.
Pretty cool. I'd like to learn how to weld.
Huh?
I'd like to learn how to weld at some point.
Yeah.
I do a lot of mechanics. Like,
Really?
yeah, I have 2 cars that I work on. They're kind of like my project.
Oh, yeah, we may work on like really
Big trucks,
diesel. Yeah.
I know diesel mechanics is something completely different.
Yeah, we're literally the same as the bigger.
Tools. It's all different.
It's full, but not the bigger.
But yeah, I'm trying to swap a Honda and I'm gonna rebuild a V8.
V8 one?
Yeah, I've got a V8 Mustang,
Hmm,
so I'm gonna rebuild it. And do some like,
46,
yeah, I'm gonna do some higher compression,
just stroke.
modification, yeah. I'm gonna do,
Okay, toss on the turbocharger.
I'm gonna do,
Oh, just all straight motor?
yeah, I'm gonna do cams and valves and stuff like that and see how much power I can make.
Yeah.
And call it a day. I'm just doing all top end. I'm not gonna open the block really.
It's better to like get your block boarded too. It's best to tossing the whole thing all at once, because once you blow a piston, and you mess up your whole
That's
block,
true, that's done.
there it goes, and you gotta buy a whole new block, so it's better to get it
Sleeping.
leave and, get it ported and polished, get it all set up and make it an innate.
I think that's what I'm gonna do with the Honda, make it a sleeve block for turbo applications.
Yeah.
Yeah, like some of the newer engines, the K series engine.
Did it VTEC?
I would like to do a VTEC.
Mm,
I've heard they hold up to better boost with turbos.
I used to actually own a
Mine is not VTEC though. I've got a single cam. It's just what came with the car from 1999.
Yeah, I used to have a Subaru, but man, it caught fire. Well, I didn't do it, but somebody did, and I had an EJ 25 in there.
Yeah.
I had the Brian Crowler 280 over 280 Cannon Stage 3.
Oh,
I had a 66 precision turbo. I had 800 cc injectors. I had a anti-latch in my car.
that thing must have flew.
I had about 600 in there.
Oh. That's great.
It was a beast, used to blow up beautiful flames. I got a picture of it.
That's crazy. The buddy of mine, his dad rebuilt one of his Subarus and he put in an EJ 25 7 or something like that. And it's the STI engine. And
Yeah.
it makes like 4 something to the wheel, but it's like an old little Outback.
Oh,
It's like it's like a legacy Outback, but it does that. It like spits flame, but
they can still go, yeah.
because he puts a turbo, or I mean he puts a 2-step, and it also has like rolling 2-step too, so you can just be rolling down the road.
Yeah, that's that anti-lag.
Yeah,
That anti-lag mode too. I used to have a blow up valve and all that.
that's crazy.
Yeah, my little brother had a Trans Am. It was built by Texas Speed.
That's cool.
Straight into the NXT. Yeah, that's his car.
Cool. Yeah. You're gonna-
Then WN6, and then my nephew's 5.0 Roush. Yeah, this was my car, but I lost it.
That's unfortunate.
Yeah, man, it's kind of cheap, man.
It's the blah blah, like.
Man, I wasn't there and some hater poured gas on my car.
Oh, that's crazy.
Yeah, so. It happened on the reservation at my mom's house. It was kind of cheap, but it's okay though. Probably by the end of the year, I'm planning on getting me a 5.0.
Nice.
Yeah.
That's awesome.
Yeah, the new ones.
Yeah, if I were ever to, I have a S95, the older one, 99, and did it something. It's got 4.6 in it, it's just a single cam. So I was eventually thinking of getting either the dual cam 4.6 or like. I think like 5.6 or 5.7 liter that they made for the Celine.
Yeah, the Red Bull GXP. Kind of knocked me, you know, I have a whole brand new stock engine, it's a 5.3 liter in there. It's a tap shit, that's all right, but. It's kind of like a family car, you know, but just imagine if you put on a show trailer and feel that center.
All right, it's a good segue into where we are moving forward in our lesson. Hopefully, looks like most everyone found their way back to break. Hopefully Adriana didn't get flooded away. Right? It's not here yet. All right. So as we continue to explore the world of ratios, once again, we look at this practical application. And so another type of ratio besides a fraction is what we call a rate, okay? And so we still have that comparison element to it, but right, our rate compares different units of measurement. So of course, the rate that we're probably the most familiar with, right, is probably miles per hour, although once again, we just talked about salary again, right? And some people make an hourly salary. So, right, so the rate of miles per hour, right, is comparing, right, miles, distance travel to time, right, time travel. I was fun to say. Rates are often expressed with the word per, right? So we know we're talking about a rate when we hear our word per, right, miles per hour, but it is a ratio. And so we can go with it like a ratio. So here's an example. A car traveled 440 miles on 11 gallons of gas. How many miles per gallon does the car get? Well, based on the data that we have, it went 440 miles with 11 gallons. So we just turn that into the ratio, simplify. And here's the thing about rates is that generally we simplify it down so that the denominator is 1, right? So that the bottom unit, the gallons or the hours, right? Because it's always 60 miles per 1 hour, right? As a speed limit, potentially. So good. So yeah. So here then, how do we write it as a rate? We know that the car gets 40 miles per gallon. Not bad. All right, so go ahead and work on part A. If you want to move on to part B, you can, but let's just warm up first with part A. Or let's just do part A together and then I'll have you. So, right, the river bridge raises 2 times an hour, which means the rate is 2 times an hour. The average heartbeat is 70 times a minute. So what would that look like as a rate?
So that's at 7 times.
Yeah, or 70 beats.
Yeah, 70.
Pardon? Yeah, just kind of reimagining it, right? So the building manager uses 1 gallon of paint to cover 3 walls. So what would that be as a rate?
So
Remember, the 1 needs to be the bottom part of the ratio or the second part?
I guess 3 walls per gallon.
Yep. 3 walls per gallon. This room gets 3 walls per gallon. Rwanda, I didn't know that was a person's name. Rwanda paid $13.50 for a ticket to last night's concert. Pretty easy, right? Yeah. All right, and one day Mike's muffler shop installs 80 car mufflers. That's quite a high demand for mufflers. Like,
They also have like the fastest workers known to
oh.
mankind. If that's correct.
I don't know where Mike's muffler shop is. I always like the one on 66 that has that weird like blue thing that's like,
Muffler has-
oh yeah. It's like the graveyard or the something for dead mufflers.
Where I got my magnum boots. It's all in 42.
They're pretty good, except they don't weld on certain types of metal, which is interesting.
Interesting. Very true. All right, so go ahead and try 6 through 9 on your own. And now here is where, right, you'll need to do that reducing step, right, to get your rates. Okay, and remember the second part of your ratio should be a 1. Okay. So hopefully you can get it down to 1. Which mostly just means you're dividing, right? Just dividing the big number by the small number, just like up here. All right, how you guys doing? Still working all day, or you got these 4? You want more time? No worries. Hopefully you folks on Zoom are following along okay and keeping up. Please always let me know if you have questions or problems. Okay. All right, So Chana drives 220 miles in 4 hours. So how many miles per hour did she drive? 55. Didn't listen to Sandy. 55 miles per hour. So yeah, right. Oftentimes, right, rates get abbreviated. Okay, there's 12 cups in 3 quarts of liquid. How many cups per quart? 4? Good, right? Because 12 over 3. Take a 3 out of there. So good. So the other way, right, that we often represent rates, right, is with the units written like a fraction, right? So cups per quart. Good. All right, Jim drove 80 miles in 2.5 hours. How many miles an hour did he drive? 32. I guess that'd be like average. Right, and we just take 80. Hopefully, most of you guys feel pretty good about using your calculator here, right? Take your 2.5, change it to 2.5, right? And then you can just plug it straight in the calculator, 80 divided by 2.5. Good, okay, and then there's 54 ounces in total in 3 boxes of cereal. How many ounces per box are there? 8 to 1. Cool. So you're definitely gonna see these types of rate problems. So setting it up like a ratio and then reducing is what we need to do. All right. So another application of ratios is this idea of unit pricing. We've already seen, I think, some examples here. So if you know the cost of several units, you can figure out the cost of 1 unit. And similarly, if you know the cost of 1 unit, you can find the cost of several units. So suppose you buy 3 pints of strawberries for $5.55. What is the unit price of the berry? So once again, we're just doing that same process, set it up as a ratio. What 2 numbers are you comparing in what order? Reduce it down. And the unit price also, right, like our rate needs to have that 1, right, as the bottom. So the strawberries are $1.85 a pint. Okay. So just the example here, right? If you know the cost of 1 item, you can use ratios to find the cost of several. Deanna bought 8 scarves that were on sale for $4.50. How much did she spend in all? Right? Since you multiplied the denominator by 8 to get 8, multiply the numerator 450 by 8 as well. Right? So we know that 1 is 450, 8 is 36. Okay, so you guys see how that works and why we did those pattern things, right? Because we just look, okay, what did I take to go from here to here? And then I do the same to the top. Okay, so try 10 through 13 using the grocery prices at in the box here and see if you can answer those 4 questions. Okay, well, 4 questions, 1 2-parter. How's everyone doing? Still working or you got it all figured out? Calculated. Well. Right. Everyone good? Yeah. All right. So number 10, what would you pay for 4 pounds of sirloin, of ground sirloin? Okay, good, right? So how did you get that number? Good, right? 299 times 4. Kind of high, but maybe it's like, I was like, well, it's ground sirloin, so maybe it's like a super fancy kind. Not like just chuck that I. All right, suppose you got a 3-pound bag of potatoes, what did you pay per pound? Yeah, good, right? And so there we do the opposite, 210 divided by, or sorry, 2.10 divided by 3. It says 0.70 or 70 cents. No, no. Luckily, they aren't adding that on top of it yet. Maybe we're in Oregon, so there's no sales tax, although I think there's still food tax. Anyway, doesn't matter. All right, what is the unit price for beef tips at Sanford Groceries? $3.99 a pound? Mm-hmm. Good, right? And we just take our $7.98 divided by 2. Okay. A customer bought 3 pounds of onions and a pound of beef tips. What did he pay?
$5.76.
Oh, okay. Well, let's see. So 3 pounds of onions, right? So 59 cents a pound. So we've got our 177 total for our onions, and then right, a pound of beef or a pound of beef tips, right? And remember, it's just 1 pound, not 2, which they, right, for some reason. So 3, yeah, I don't know. I didn't do it. I don't know where it's 30. Oopsie. Oh, we're getting $5.76. And then part B is kind of silly, but hopefully everyone felt good about that, right? So then we just take our $10 and should get $4.04 back in change.
I don't have enough money. I can't really it's not that much.
Oh, yeah, that could definitely.
How does that mean?
I did the same.
No worries, no worries. That's why we're
Then he
practicing.
said onions and I'm like, oh.
I know I have one.
Of course.
That is what I have.
So close. Okay. All right. So, all right, so just. All right. Hopefully everyone's feeling good. There's just some more ratio practice here. I don't know if you guys feel like you need more practice. But if you want to, you could look at pages 52 and 53, which just have you, work on that. But let's jump to the word problems that are on
it says 57 down in the bottom corner here, and there's 6 word problems. So why don't you guys work on those? So yeah, 57. It says ratio and rates word problems. And then Alonda. How's everyone doing? Still working a little bit? Maybe 3 more minutes? Sounds good. All right, anyone still working? No. All right, even if you're not all the way done, let's go ahead and talk about these. How did they feel? Pretty doable now that we kind of teased through all of this, or did it still feel a little confusing? And we'll probably work more on this one as we go on, but, okay. Yeah. Okay.
Those were kind of tricky.
They're adding kind of another layer that we didn't look at. I don't know if any of you guys saw the hints up here. We're gonna work on this next Tuesday, because this is a little bit more advanced, but like I said, I wanted to kind of, you know, just dial the difficulty up just slightly, just this, because this is pretty close to like the GED style ratio questions. And, you know, we just kind of did that basic stuff. But here's basically what you're always trying to do. So there's always going to be something you don't know and something you do know. So, so for example, if we look at number 1, right? So we know that, right, there's 10 soft drinks for every 12 guests. I guess everyone else gets booze. I don't know. Right? So we have a 10 to 12 ratio. Okay. And so then, right, we can say, okay, how many soft drinks, right? That's our missing total here. If there's, right, 252. Okay. So then what this is telling us up here is that then, right, we do something called cross multiply and then divide. So, right, so we would cross multiply 12x equals 2,520. Oops, got my x. Okay, right? I cross multiply and then, right, divide both sides by 12 to get x by itself. So Oopsie doodle. Oh, oops, that's fine. I didn't hit enough buttons. 2520, there we go. Right? So 210 drinks, right? So if the ratio is 10 to 12, then if there's 252, then it's 210, 252. Does everyone see how the setup works here? So you can kind of do it two ways, right? So, you know, for me, right, instantly you look and see, okay, right, I have, right, so here's my first ratio that I know, and then here's my unknown. So based on the two numbers that I have, I just instantly divided those, right? I just took 252 and divided by 12, and I got 21, and then, right, you multiply 21 by 10, and you also get,
I was just in that aspect, so I was like,
Yeah.
that's 21.
yeah.
So when you do that, you can.
Yeah, because that would be at the top, right? So it's like 252 divided by 12 is 21. So to make the equivalent fraction, then we multiply the 21 by 10, and that's what goes up.
You're not even writing out.
Hey, no, that's fine. That's the goal. So luckily on the GED, as far as I know, you don't have to show your work. I don't think you can show your work. And so, yeah. So as long as you can find that answer, that's of course the main goal. Finding it with confidence and knowing why you found it would be like, you know, a nice icing on that cake. But we still got cake, so, you know, great. Okay, so number 2 is a little different, right? We're kind of comparing two ratios, right? So in Jack's class of 18 student, or sorry, in Jack's class, 18 of the students are tall and 10 are short. Don't know how they're determining that, but right, so we have 18 tall to 10 short, right? And then in Michael's class, right, versus Michael's class, which is 54 tall to 30 short, right? And so we just figure out which has the higher ratio. So how do we figure that out?
Self multiply.
Nope. So what do we do?
Reduce them, I think.
Yep, exactly, right? We need to reduce them down to their smallest unit, so it's easier, right, to compare. So what does 18 over 18 to 10, good, is a 9,
The 5.
right? And then what would this one be? Okay. Mhm. We take let's take a 6 out of both, right? So, yeah. So which one has a higher ratio? Is 9 to 2 a higher ratio than 9 to 5? Yes, right? Because there's more tall people to short people in Jack's class than tall people to short people in Michael's class. So, yeah. So Jack's class has the higher ratio of tall to short. Okay, does everyone see how this is a higher ratio? Because, right, the difference between the two numbers is bigger than the difference between these two numbers. Are these two ratios equivalent? So it's the same thing, right? We just reduce them and compare. Are they the same? Mhm. Right, because they both reduce down to 1 to 6, right?
Yeah, like, I can read it.
Good. So sometimes it's just reduce them down so we can compare them. Other times, right, we have a missing value that we have to find. So those are kind of the two major ratio type questions, right? Or we get these units and rates, of course, as well. The price of 3 apples at the Quick Mart is $1.44. The price of 5 of the same apples at Walmart is $2.50. which place is the better buy? Okay, why?
You get for like, it's gonna be a little bit more, to get, like, you'd be able to pick six apples, I guess, for the price of 55. Get an apple extra for like.
Yeah, right, so if we have the 3 apples for $1.44, right? Is 48 cents an apple, right? Or 48, yeah. Right, 48 cents per apple. Oh, I did that upside down, I'm sorry, guys. Sorry. Oh, okay, sorry, just switch that around, right? So 48 cents per apple at the Quick Mart, and then right at Walmart. 50 cents an apple, so yes, right? Quick Mart apples are cheaper. Right, so yeah, that's where you just, right, find that. What is the price of one apple in each place, and then, right, which one is cheaper? Does that make sense? So just multiple or divide your big number by your small number, big number by your small number. And that gives you your price per apple. Mateo, you hanging in there okay? Cool. Excellent. All right, number 5, the bakers at a bakery can bake 160 bagels in 4 hours. How many bagels can they bake in 16 hours? How did you get that?
Times the 4 to 16, or the 4 to divided into 16 was 4. Times the 4 to 6.
Good. Right, so you can set it up again like this, right? So you could multiply it or kind of cut out a lot of the steps like Spencer's telling us. So, right, we know, okay, if it's 160 per 4 hours, right? Then if we divide that, we know, right, it's 40 bagels an hour. So then, right, times 16 hours, we're making 640 bagels. That's a lot. Delicious bagely carbs. All right, oops, not $640, 640 bagels, silly. Bagels. Okay. You can buy 5 cans of green beans at a supermarket for $3.40. How much does it cost to buy 35 cans? And how did you figure that out?
Times 340 and 5.
Okay,
Or first I divided 5 into 35.
Yep. Good, right? Because of course, right, the difference between 5 cans and 35 cans is 7 times, right? Basically, right, 7 groups of 5 cans, right? So yeah, we would just take our 5 can price and multiply by 7, so we know what 35 cans cost. Beautiful. So 7 times 3.4, whoops, 23. That's a lot of green. All right, so $23.80. Good. Awesome. You guys are, oh, and like I said, we'll just keep working more and more on these. I think that we're at a good stopping point for today. This is probably kind of how class will go. And don't worry about being overtime, but you can always work backward on any of the extra practice that we went skipped, and then otherwise just hold on to this. And on Tuesday, we'll start this chunk on proportions, even though we already kind of started on it. But I think we're at perfect stopping point, so. All right, any other questions or concerns I can help with since we're done a little early today? Maybe it is.
Just the word problems I'm kind of struggling with because I don't know how to write it. I write it the wrong way and I just need more work on it.
Okay, that's good, that's helpful to know, Sam, so, we can definitely write them out more, and there should be opportunities for more practice with these types as we continue through the rest of the lesson. So I'll make sure that I kind of write it out a little bit more clearly and a little less abbreviated, okay? Does that help? Okay, cool.
Yeah,
All right, well, have a fabulous rest of your day if I don't see you in any other classes. If not, I might see you, I'd be glad to see you guys this afternoon. All those this afternoon. So we've got social studies at 1 and science at 4. And then language arts at 5:30.